If a rocket launch is like a stunning dance performance, then the launch tower is the stage where this incredible show happens. For the performance to be flawless and safe, a strong and reliable stage is essential. SpaceX has mastered this, building large, efficient launch towers that keep getting better over time, all while being cost-effective. This success has put NASA's mobile launch tower to shame. But why is that the case? What issues is NASA dealing with when it comes to its own launch tower? All of this will be uncovered in today's episode. Recently, rocket enthusiasts have been buzzing with exciting news from the Boeing Starliner setbacks to the upcoming Starship flight and SpaceX's ongoing issues with the FAA. Amid all this, there's a major engineering project at Starbase that's quietly making significant progress. This project, potentially the tallest of its kind, is none other than Starship's Ol-3, the second launch tower at Starbase. The foundation was laid on June 13th, and as of now, the tower has reached its 7th segment of assembly. The tower's construction has been impressive, though it could have moved even faster. The first 6 segments were completed at an astonishing pace, showcasing SpaceX's efficiency. After building a solid base with piles, steel plates, concrete, and strong foundations, SpaceX began stacking the Ol-3 modules at a rapid speed. The first major milestone came on July 11th, when the initial module was placed on the base. Just 5 days later, on July 16th, the second module was stacked. This momentum continued with the third and fourth modules being installed on July 18th and 25th, respectively. The installation of the final 2 modules was particularly impressive. Just a week after completing the 4th module, SpaceX smoothly placed the 5th module into position on August 2nd. Then, in just 2 days, the 6th module was fully installed on August 4th. On average, it took SpaceX less than 4 days to assemble each segment of the tower, a remarkable speed that far outpaces their previous efforts and sets a new standard in the space industry for the rapid construction of rocket launch infrastructure. However, the swift pace hit a brief slowdown with the 7th tower segment, which took SpaceX up to 12 days to start and complete. What caused this interruption? SpaceX is using the DMAG CC888001 crane to stack the pre-assembled modules for the new Starship launch and landing tower in Boca Chica. A few days ago, the crane had to be lowered for an extension, which involved adding new parts to the main boom and jib. By August 9th, the extension work was finished, and the crane was raised, with the upper part of the boom resting on a replacement support. However, as the crane was being raised, the backstop hydraulic cylinders, which are supposed to retract as the boom goes up, seemed to have locked in place, causing them to tear free from their mounts under pressure. SpaceX quickly repaired and reconfigured the crane, and it was soon back in operation, standing tall and ready to continue its work across the Starbase skyline. Honestly, this was just a minor hiccup in SpaceX's construction process, so there's no need to worry too much. The pace of work is expected to pick back up soon. We'll likely see new progress on the launch tower shortly, along with advancements at the new launch pad. Yes, you heard that right, a new launch pad is in the works. The launch tower is just one piece of the puzzle. 2 weeks ago, SpaceX announced plans to expand the launch pad area, including the addition of new water and fuel tanks to support 2 launch pads. A map released by the FAA gives us a glimpse of SpaceX's vision for expanding Orbital Pad B. While the new design suggests that the current orbital pad will look quite different from the proposed version, it still aligns with what we expect from SpaceX. They're also building a flame trench, and a space engineer even shared a simulation on X, showing how this project might look once it's finished. A big thanks to that engineer for those amazing renderings. The final result is bound to be something impressive that we all can't wait to see, but for now we'll just have to wait and see how it unfolds. Everything SpaceX has accomplished truly leaves NASA scientists in awe, especially when compared to NASA's own launch systems. Take the Mobile Launch Tower, for example, the system used to launch NASA's vehicles during the Artemis missions. The first version, known as Mobile Launcher 1 ML1, was initially built in 2009 as part of the Constellation program. When that program was canceled, ML1 was repurposed to launch the SLS Block 1. The entire process, from its initial creation to its conversion and eventual completion, took nearly 10 years and came with an estimated cost of around $1 billion. ML1 was put to use for the Artemis I mission until November 2022. Unfortunately, the tower sustained damage during that mission and had to undergo repairs to be ready for the Artemis II mission, which will include a crewed flight. After more than a decade and significant funding, that's all NASA has achieved with the Mobile Launch Tower, which is even more disappointing given that it will only be used 2 more times during the Artemis II and II missions. From Artemis IV onwards, NASA plans to use the SLS Block 1 billion, which requires a different, smaller but heavier launch tower. This need led to the development of a new mobile launch tower system, known as ML2. The planning for ML2 began in 2019, and construction started the following year, with Bechtel as the main contractor. Initially, the construction was expected to be completed by early last year, with an estimated cost of $383 million. However, the project has faced significant delays and rising costs. To date, the construction of ML2 is still incomplete, with the total cost ballooning to $960 million, 2.5 times the original estimate. The project's handover to NASA has now been delayed until October 2025, more than 2 years behind schedule. Even with this extended timeline, multiple audits have raised concerns that Bechtel might still not meet this deadline. Bechtel has attributed the delays and increased costs to the impacts of COVID-19 and rising prices. However, the underlying issues seem to stem from both sides. NASA awarded the contract to Bechtel before the final specifications for the ML2 system were even complete. Meanwhile, Bechtel underestimated the project's scale and complexity, leading to inefficiencies and delays that have significantly increased costs. So, it seems it could take another half a decade or more for NASA to finish their second mobile launch tower ML2. If last year's investigation revealed nearly $1 billion in costs, the final price tag could be astronomical by the time it's all said and done. While some may argue that the pandemic severely impacted NASA and its contractors, this explanation doesn't fully hold up, especially when compared to SpaceX's progress during the same period. SpaceX, working under similar global conditions, developed the Mechazilla system and orbital launch mount OLM. Starting with the first concrete piles in July 2020, they managed to have both the OLM and the launch tower essentially completed by the end of 2021. This stark contrast highlights how efficiently SpaceX has been able to work, setting a new standard for speed and effectiveness in the space industry. This comparison highlights how NASA and Bechtel's justifications for delays and cost overruns seem to further expose the inefficiencies in their operations. On the other hand, even though SpaceX has set a new standard in speed and innovation, catching Starship with their launch towers remains a formidable challenge. SpaceX has made the process of recovering and reusing the Super Heavy booster and Starship more complex by eliminating the traditional landing legs. Instead, they've designed their latest prototypes to be recovered using a massive mechanized launch tower. In this process, the rocket approaches the tower, enters the gap between the chopstick arms, hovers in place while the arms close around it, and finally comes to rest on small hard points that offer about as much surface area as a coffee table. Elon Musk has shared simulations of this process, but the term catch might be misleading. The arms move only in one direction. They open and close but don't actually grab the rocket in any conventional sense. As currently designed and shown, these arms function more like a small, fixed landing platform that can make slight positional adjustments at the last moment. If SpaceX's chopsticks system for catching rockets eventually succeeds in reducing post-recovery processing time by eliminating the need for cranes or additional attachment processes, it could offer significant advantages. This approach could also lower the dry mass required for landing legs, though interplanetary ships will still need them. However, proving the system's efficiency will be a challenging task. The current recovery mechanisms on the chopstick arms and the landing hard points on the rocket suggest that even a small deviation from a perfect landing could result in failure. If the rocket stage is just a foot or two off from the ideal position or slightly rotated, the catch might fail. This could cause the massive, pressurized, and partially fueled rocket to crash into the chopsticks, potentially causing a catastrophic explosion. Such an explosion could damage surrounding infrastructure or ignite fires. We really hope the rocket doesn't hit the launch tower, especially the launch ring, which is extremely complex and challenging to build. The launch ring is a crucial part of the infrastructure, and damaging it would be a significant setback. Given the risks involved, SpaceX will need to be exceptionally cautious with their catch attempts. If the design isn't nearly perfect from the start, the company might need to use many ships and boosters to avoid damaging their only Starship launch tower. SpaceX is aware of these risks. For a catch attempt to be successful, the Super Heavy booster must be in excellent condition and perform flawlessly during both ascent and boost back. Starship's first orbital launch could turn out to be even more impressive than anticipated, making it a truly remarkable event in space exploration.